Hello. So welcome to the series of linear integrated circuit, and in previous lecture we have seen the unity gain amplifier. So now we are going to discuss about adder or summer. It is also called as summing amplifier. So basically this is a kind of inverting amplifier. Means all the inputs we will connect at inverting terminal, and we will see that what kind of output we are getting, and it is desired to be a summer that output should be the sum of the input voltage applied at inverting terminal. So we can make it circuit, since this is the inverting kind of amplifier, so all the inputs will be connected at inverting terminals. So now we are making the circuit of summing amplifiers. So let's say we are having the circuit. We are taking output from this terminal. This is V output. This one is inverting terminal. This is non-inverting terminal. So this terminal is V1 and this terminal is basically, this is V2, and the voltage difference is VID. So this is the voltage difference between V1 and V2. And we have two external DC supply. One is plus VCC, another one is minus VCC. So now, since this is the inverting kind of op amp, so here we are going to connect multiple voltage source. Let's say this is the VA, and the resistance is, let's say, RA, and one more voltage source is VB. Let this resistance is RB, and we are taking one more voltage source as an input, that is, let's say, VC, and we have this resistance as RC, and these all three branches are connected with inverting terminal. So this is the circuit, and since this is the inverting amplifier, this is a kind of inverting amplifier, so a non-inverting terminal should be grounded. So this becomes the circuit, and obviously this is the closed loop configuration of op amp. So we need to connect a feedback resistance here. So this resistance is RF, that is called as the feedback resistance. So this becomes the circuit of summing amplifier. So now we need to do the analysis. We just want to find out that what should be the output voltage. So first we have to apply by applying virtual ground concept. We know that here we know that V1 is equal to 0. This voltage V1 is grounded, so this voltage is grounded, so V1 become V2, and we know that whatever voltage present at in non-inverting terminal, that should be automatically reflected to inverting terminal, considering infinite gain. So we know that gain is equal to V output. This is the ratio of V output divided by VID. So this become V output divided by V1 minus V2. So V1 minus V2 is V output divided by A, and if we are considering this gain as infinite, so this implies V1 is equal to V2. Here we have V1 as 0, so V2 will also become 0. So this is V2 will also become 0. This is by virtual ground concept. That means this V2 here at non-inverting terminal, this V2 is 0, because this V1 is also 0. So we will apply this virtual ground concept. Now we just make a notation of current flowing in each branch. So here we can see that current flowing in this particular branch VA RA. Here let's say current is IA. In second branch the current is IB. In third branch let's say current is IC, and these three currents are going towards this node. Let's say A is the node, and the current going inside to this operational amplifier, let's say this is I2, that is always 0 because of infinite input resistance. These two terminals are isolated, inverting and non-inverting terminal. These two terminals are isolated, and the feedback current here is IF. So at node A, at this point at node A, we can say all the incoming currents, here we have the current IA. What will be the current in this branch? IA plus IB plus IC is equal to, what is this? I2 plus IF. So at node A, we can write here, at node A, we can write IA plus IB plus IC, means IA plus IB plus IC is equal to I2 plus IF. We can write here I2 plus IF. This is very important equation, and we can see here that this I2 current is 0. Why it is 0? Because our input is infinite. We have considered input resistance is infinite. So now we can put the values of these currents. How can we write the values of these current? Here IA will be the difference of this voltage VA minus here voltage V2. So VA minus V2 divided by RA. The voltage difference will be VA minus V2 divided by RA. The voltage difference VA minus V2. This is the voltage difference, and resistance in this branch is RA. So divide by RA will become the IA current. So we can write here VA minus V2 divide by RA. This is the current of IA, plus similarly IB will become VB minus V2 divide by RB, and similarly IC will become VC minus V2 divide by RC. That will be is equal to IF. Now see what will be the feedback current. This IF will be this voltage V2 minus V output, because RF is connected between inverting terminal and output terminal. So V2 minus V output divide by RF will be the feedback current. So we can write here V2 minus V output divide by RF. So this will become IF. Now we need to analyze this, and we remember, since V1 is equal to 0, we can write here, since V1 is equal to 0, hence by virtual ground concept, V2 will also become 0. So we can write this V2 value as 0 in this equation 1. So here from equation 1, we can write as, this is VA minus V2. So this become VA minus V2 is 0 divided by RA, plus this is VB minus V2. So V2 becomes 0 divided by RB, plus this is VC minus V2. V2 means 0 divided by RC. This become V2 minus V output. V2 is 0, so 0 minus V output divided by RF. So now we can simplify it like, so it will become V output is equal to, V output is equal to, what we can say? We can write it as V output is equal to, this is VA, this is minus times VA into RF divided by RA plus VB into RF divided by RB plus VC into RF divided by RC. So this become the output voltage. Or in a proper sense, we can also write this equation as V output is equal to minus of, let's say, minus of RF upon RA into VA, and then again minus of RF upon RB into VB, again minus of RF upon RC into VC. So if this RF will become RF and RA and RB and RC, these all resistances are of same value. If these all resistances are of same value, so we can write here output as minus of, so these RF and RA become same. So what will be the value of this term? This term become minus of VA. So we can write VA plus VB plus VC. So basically what is the output? Output is the sum of all the voltages applied at inverting terminal. And what is this negative sign? Negative sign represent that there is a phase shift of 180-degree between these sum and the output. So this is the summing amplifier. For a particular condition, this can provide the sum of all the input voltages applied at the input terminal. So this is a kind of inverting amplifier in which we have connected so many inputs to get a summing amplifier, to get a sum of all the inputs. So again we can write here, if we have, if there are n number of input voltages applied at inverting terminal, n number of input voltages applied at inverting terminal, then what will be the output? Then we want to calculate the output. So we can make a circuit again. So let's say this is the op amp. This is inverting terminal, non-inverting terminal. This is V1. V1 is grounded, and we have output here. This is the inverting terminal, and we are connecting a feedback resistance here. So this is RF, that is a kind of feedback, and we are connecting n number of inputs. We have n number of inputs. Let's say V1, R1, one input is V2, let's say resistance is R2, one input is V3, let's say resistance is R3, Similarly, Vn, let's say resistance is Rn. So these all branches are connected with inverting terminal. So here the current is, let's say, capital I, and inside of this op-amp current is I2, and this is the feedback current IF. We are already having positive voltage and negative DC supply, power supply. So again, we can write the output of this an input summing amplifier as, what will be the output? Minus of RF divided by R1 into V1. Similarly, minus of, or we can take minus as out. So this become plus RF divided by R2 into V2 plus RF divided by R3 into V3 plus, and so on. For nth term, we can write RF divided by Rn into Vn. So this will be the output expression, and if we will apply a condition, Rf is equal to R1 is equal to R2 is equal to R3 is equal to Rn, that is equal to R. So if we will apply this condition, so output will be the simply minus of sum of all the inputs connected at inverting terminal V3 and plus this is Vn. So this is the output of this summing amplifier. So this become the adder. So for n number of inputs, we can also calculate the output. So hope you have understood this summing amplifier or adder concept. So thank you for watching, and in next video we will see different numerical based on